Factorizing a trinomial with a coefficient. Factorizing something that's ax squared plus bx plus c, where a is not equal to 1. So we've done things like this, x squared plus 5x plus 6, and we could factorize this into x plus 3 and times x plus 2. Okay, but what if we had something like 8x squared plus 22x plus 15? We haven't done anything like this, but we're going to learn how to do that today using a method called splitting the middle term. This is our middle term here. So let's take a look at this again. So if we try to do this one here, using the method we know from before, our sum and product, we need something that multiplies to be, that these two are multiplied, and where it adds to 22. Well, we need something that multiplies to be 15 and adds to 22. Well, that doesn't make any sense. But what if we did something that it was 8 times 15, 8 times 15, that gives us 120, and adds to 22. Well, 12 and 10 gives us 22, and 12 times 10 is 120. Okay. So could we use something like x squared, or just rather x plus 12 and x plus 10? Well, no, because when we multiply this back out, we're going to get x squared plus 22x plus 120. So this doesn't work here. All right, so we're going to have to use a different method. All right. So we've done things like this, all right? However, if a is a common factor, okay, we could take it out. So if we had 2, 10, and 12, we could take out the 2, and then we're left with something like this. Not a problem. Okay, and then we have perfect squares. So if we have something like this, a square minus a square, well, we know how to do that as well. However, this example doesn't fall into those. Okay, there's nothing that 8, 22, and 15 share. All right, so that doesn't work. And they're not perfect squares, so that doesn't work. So we need to develop a method for factorizing this type of expression. So we're going to factorize by splitting the middle term. Let's see what that means. So if we have this, and we FOIL, 2x times 4x is 8x squared. Okay? 2 times 5 is 10x. 3 times 4x is 12x, and 3 times 5 is 15x. Combine our like terms, 8x squared plus 22x plus 15. Okay, so we know this is going to be the answer to that, but how did we get that in the first place? So we're going to go backwards. We're going to reverse this. So 8x squared plus 22x plus 15. All right, we're going to split the middle term. If we're going to split the middle term, we need to change it into two different numbers. So for 22, I could use 1 and 21. I could use 2 and 20. Any combination that gets me to two numbers that add to 22. There is a reason, though, that we chose 10 and 12 here. We'll get to that in a second. Then we're going to group in pairs. So I'm just going to put a parenthesis or a bracket around, just like that. Okay? And we're going to factor out a common term. So out of this, I can take a 2x, leaves me with 4x plus 5. Out of this, I can take a 3, leaves me with 4x plus 5. From here, we complete our factorization. So these two go together into this one, and we have a 4x plus 5 and a 4x plus 5. What's really happening is we're dividing this 4x plus 5 out of both of these and coming out front, and that leaves us with a 2x plus 3. So let's talk a little bit more about this example. How do we know we split it correctly? How do we know that there should have been 10x and 12x and not 15x or 7 and 7x or anything else? Well, if we look here, if we do 8 times 15, that gives us 120. All right, so we need two numbers. If we add them to be 22 and multiply to be 120, well, that's 10 and 12. So for 8x squared plus 22x plus 15, we need two numbers whose sum is 22 and whose product is 8 times 15, 120. Those two numbers are 8 and 12. Okay, so let's look at another example here. 6x squared plus 19x plus 15. All right, so we need two numbers with a sum of 19 and a product of 6 and 15, which is 90. So without looking over here too much, we need to multiply to be 90 and add to 19. Well, 10 plus 9, and then 10 times 9 gives me 19, 90. All right, from here, I'm going to have it 6x squared plus 10x plus 9x plus 15. Okay, and then we just group them. We take out what they share, 6x squared plus 10x. They share a 2x. And I'm left with 3x plus 5. And out of here, I can take a 3. And I'm left with x plus 5, or rather, (3x plus 5). Okay, now we divide this 3x plus 5 out of both, and it comes out front. And we're left with a 2x plus 3. Now, you might be wondering, hey, how did you know to put the 10 first and then the 9? Is it always the bigger number first? Well, no, it's not always the bigger number first, because on this one, we did the smaller number first. In fact, it doesn't matter which one we do first. So if I do this again, and I'll do it in blue, now I'll just take what we had here. I do 6x squared. And this time I'll do plus 9x, plus 10x, plus 15. Okay, from here, we'll do the same exact thing. Well, out of this one, I can take out something slightly different. I can take out a 3x. 3x leaves me with 2x plus 3. And up here, well, I can take a 5. It leaves me with 2x plus 3. Now we divide this 2x plus 3 out, put it up front, and we're left with a 3x plus 5. Okay? And because we know in multiplying, it doesn't matter which order we go, these are exactly the same answer. So our steps, okay, find two numbers. If we have something like this, find whose numbers P and Q, whose sum is B, whose product is AC. Okay, replace BX by PX plus QX, complete the factorization. All right, pause the video, try these two, and then come back. Okay, for A, similar to the other one we did, we need something that multiplies to be 6 times 10. So 6 times 10 equals 60. We need something that adds to 19 and multiplies to be 60. Okay. Well, 1 and 19 is not going to do it. That only adds to 20. Okay, well, how about 15 plus 4? So 15 plus 4 is 19. And 15 times 4 is 60. There we go. We found our 2. Okay, so 6x squared plus 15. Again, it doesn't matter. 15x. Doesn't matter which one comes first. It's still going to work. Plus 10. Then we group them. Take out common terms. So out of here, I can take a 3x. Gives me 2x left. Plus 3. Out of here, I can take a 2. It gives me x plus 5. I'm sorry, on this one. If I took out a 3x, I would get x plus 5. And then I would leave with 2x. If I divide by 2, I get 2x here. So I'm left with 2x plus 5 and 2x plus 5. That can come out front. and I get whatever's left, 3x plus 2. There we go. Okay. On B, if you didn't get this one right, okay, go ahead and try B again, just to double check and then come back. Okay, B is a little bit tougher because we have some negatives. So we need something that multiplies to be negative 30 and adds to, well, negative 1. So we need something that multiplies to be negative 30 and adds to be negative 1. We could do, well, let's see what goes into 30. Not very much. 30 and 1, 10 and 3, 5 and 6. Okay, 5 and 6 are close. They might add to negative 1. Yeah, if I have negative 6 and positive 5, if I add those together, that's negative 1. And negative 6 times positive 5 is negative 30. Okay, so that works. So 3x, not 30, 3x squared minus 6x plus 5x, okay, minus 10. Group them and factor out. So we can, out of here, we can take a 3x. We're left with an x minus 2. Out of here, I can take a 5. And I'm left with x minus 2. And boom, we can see it's going to be x minus 2 and 3x plus 5. I want to do this one again, and I want to just order these differently. What if we did 3x squared plus 5x minus 6x plus 10? Okay, from here we can take out the x, we can see that, and we're left with 3x plus 5. Okay, we can see that's going to come down here. And from here, if I take out, let's make this a little bit bigger, negative 6x plus, or minus 10. Negative 6x minus 10. All right. From here, this is just this brought down here. Okay, we want to get this 3x that we got up here. Okay, because otherwise our grouping's not going to work. Well, I can take out, if I just take out a 2 from here, if I just take out a 2, I'm left with negative 3x minus 5. That doesn't help me. I can't, when I put it together, I'm not going to be able to divide those out because they're different. So we can't do that. Instead, we need to take out this negative. So we divide by negative 2, and we get 3x plus 5, okay? And there's negative 2 on the outside. And then we have x times 3x plus 5 minus 2 times 3x plus 5. We divide 3x plus 5 out, and we're left with x minus 2. Same exact thing, okay? When we have negatives, it gets a bit trickier, but again, if you just follow the rules, not too bad.